Hello and good day, pre-algebra. We are skipping over CO35 and doing something much more fun in CO36, which is looking at whether or not an equation or an XY table, as you see further on down, contains direct variation, okay? And rather than jumping right into that definition of what direct variation is, I've got examples here, 3 of which show direct variation, and 3 of which do not, okay? And I'm giving these to you as equations in slope and intercept form, but I want you to visualize what is the line of each of these going to look like, and what do these 3 have in common that might explain why we would say they have this thing called direct variation, and what these 3 over here have in common, which we might lead to say they don't have direct variation. What do you notice about those equations, but also the lines of the graphs that they would make? What do each set of 3 have in common? Yeah.
The direct one, the y-intercept is 0, 0.
Right, exactly. Okay. If you look at all 3 of these that are direct variation, it looks like we're missing that b, right? We're missing that constant, that plus something or minus something. Of course, we know that we're not really missing it. We just don't need to write it because it's plus 0, right? And adding 0 to something, because it doesn't change the value, we don't actually have to write it. Whereas the 3 that are not considered direct variation, all of these have something written there. Plus 2, minus 3, plus 7, okay? Something other than 0. So what we're looking for, and then as far as the lines of these graphs here, the graphs of these equations, where are they all going to pass through on the y-axis? Having a y-intercept of 0 means they pass through what special point? What are we? Yeah. The origin, right? 0, 0. So all of these lines, oh, that's a terrible corner plane. Oh my goodness. All of these lines are going to pass through the origin here, okay? Whereas these 3 over here are going to pass through at different places. It doesn't make a difference. What makes something have direct variation is it passes through the origin because the y-intercept is 0. And what we're saying here is that if we make a function table for y equals 2x, you had to do this back in PO 2024, how do you get from x to y? If I give you a value for x, what do you need to do to it to get to y? What does that equation say? If I said in this first equation x is 4, what's the value for y? Aiden?
0.
Nope. If x is 4, y equals 2 times x, and I said that x is 4. I heard someone say it, but now I'm struggling with, what did I just do? How do I undo? Oh, brother. I think I got to go to my computer. Someone said 8, right? And the reason why it would be 8 is because in that equation, y equals 2x, that says y equals 2 times x. If x is 4, 2 times that gives us 8. What would y be if x is 6? 12. What would y be if x is 10? 20. Okay? So we had 4, 8, 6, 12, and then we had 10, 20 as well. So what did you need to do to get from my given x value to the y value? You just multiply by 2. And that was it. It was a direct path to get from x to y. In this second equation, if I give you a value for x, what would you do to that value to get y? Aiden? Multiply by 2/3. That's it. Just one thing. If I gave you a value for x in this third equation, what would you do to that value to get to the y value? Multiply by -4/5. Okay? In all 3 of these, it's just a one multiplication step to get from the x value to the y. Whereas over here, if I gave you a value for x, you need to multiply by -3 and then add 2. It's not a direct relationship. You'd multiply in the second one, multiply by 7/6 and then subtract 3. You don't get there directly. There's two things that you need to do. Y equals 8x plus 7, multiply by 8, and then add 7. Okay? So direct variation is essentially an equation that's written in y equals mx form. Okay? There's no b because it passes through the origin. It's a +0, so you don't have to write it. Right? Direct variation, and what this means is that there's a hold on. X and y are proportional. Okay, our whole next unit is going to be on ratios and rates and proportions and things like that. Here we're going to start to get a taste of that. Okay, X and Y are proportional. And the constant of variation is found by taking Y divided by X. And we'll get more into this when we do some examples here. Y divided by X, and it's also the M variable in that equation, which means it's our slope. Okay? Found by taking y divided by x, which gives you m, which in our equation is the slope. So in y equals 2x, what's the constant of variation there? What's the slope of that line? Think slope-intercept form. It's that coefficient to x. Aiden?
2 over 1 or just
2 or 2 over 1. What's the constant of variation in the second one? Y equals 2/3 x. What's the slope of that line? Aiden again.
2/3.
2/3. The third one, y equals -4/5 x. What's the constant of variation in that one? Go ahead, Leo. -4/5. It's the slope. Okay. So given an equation, it's very easy to see whether or not direct variation exists because you're just looking for is there a b? Is there something being added on or subtracted after that? I'm going to scroll down so we can get the definition along with the examples here, because we're going to focus today on direct variation with a function table. Okay, and what we're looking for here is for each ordered pair. For each ordered pair, calculate y divided by x. We had that written up in the definition above too for constant variation. Okay, for each ordered pair in a function table, calculate y divided by x. If all are the same, then direct variation exists. Okay? For each ordered pair, calculate y divided by x, and if all are the same, direct variation exists. So, for that first one, okay, we look at our ordered pair, 2, 4 here, and we're going to take 4 divided by 2, right? Y divided by x. What is 4 divided by 2? John, 2. All right. Then we go on to the next ordered pair, 8, 16, and we again take y divided by x. 16 divided by 8. What does that equal? 2. Okay. Then we go to our next ordered pair, 10, 20. 20 divided by 10, y divided by x equals what? 2. And then we go to our last ordered pair here, 12, 24. We're taking 24 divided by 12, y divided by x, and we get what? 2, right? So it says, for each ordered pair, calculate y divided by x. We just did that here. We went through all 4 of them. We took y divided by x for each of them. It says if all are the same, then direct variation exists. So because these 4 answers are all the same, yes, direct variation exists. Okay? When we defined constant of variation, we said the constant of variation is what you get when you take y divided by x, and it's the slope of the equation. So the directions up above say determine if each function table shows direct variation. We did that. If it does, find the constant of variation, which remember is y divided by x. That's what we did 4 times here, right? And so the constant of variation is going to be 2, because that's what we got every single time when we took y divided by x. The third part of these directions say write the equation of the line in slope-intercept form. Well, knowing that that constant of variation is our slope, our equation in slope-intercept form is just going to be y equals 2x, which happens to be the exact same equation that we started with up in our example above of direct variation. Okay? We found that too. That's the important part here. We found that too by for each of our 4 ordered pairs calculating y divided by x. Because all 4 of those calculations gave us the exact same thing. We knew it was direct variation, and that 2 was our constant of variation as well as our slope. Okay, follow me? Questions from anybody? All right, let's look at the next one here. Okay, actually, let's skip this one and go to the third one so I have more space to write. You don't take up as much space to write as I do, I hope, but here we go. So looking at that third one, we start by taking 6 divided by 8, right? Y divided by x. And 6 divided by 8, does that work out evenly? No. So in this case, I'm going to leave it as a fraction, 6/8, but in simplest form, which is what? Someone I haven't heard from yet today. The fraction 6/8 in simplest form. Yeah. 3/4. Okay. So if all of my other divisions here for every other ordered pair, if all of them equal 3/4, then direct variation does exist. If even one of them equals something else, then it doesn't. They all have to be the same. So I go to my next one. 18 divided by 24, 18/24. Does that fraction simplify to be 3/4? Yes, it does. Okay, so far we are on pace. I go to my next one. 30 divided by 40. Does 30/40 equal 3/4 in simplest form? Yes, it does. I'm 3 for 3. I go to my last one. 12/8. I take y divided by x, 8 divided by 12. Does 8/12 simplify to be 3/4? No. What does 8/12 simplify to be? 4/6, but go in simplest form. Sorry?
4/3.
Nope. 2/3. Okay. Divide both 8 and 12 by 4, we get 2/3. This one is a problem. Okay. It's different from all the others, which means that direct variation does not exist. No direct variation. Okay. And if there's no direct variation, is there a constant of variation? Nope. Okay. Which means that this equation cannot be written in slope-intercept form. Okay. Let's look at the last one. Again, just for more space to write here. Okay, start by taking y divided by x. Again, that 14 divided by 6 doesn't work out evenly, but that's okay. What is the fraction 14/6 simplified to be? 14/6 divided by the greatest common factor. Looks like it's 2 7/3. 14 divided by 2 is 7. 6 divided by 2 is 3. Okay. Negative 35 divided by negative 15. Put that in simplest form. The negative signs cancel out. So really you're just looking at 35/15. Find the greatest common factor. Divide both numerator and denominator by that number. What do we get? Aiden? 7/3. And it's positive because we have those two negative signs that cancel out. The next one, negative 21 divided by negative 9. Again, taking that y divided by x. Negative 21 divided by negative 9. Negative signs cancel out again. That's fun. So we have 21/9. What's the greatest common factor? Simplify that fraction down. What do we get? 7/3. So we're 3 for 3 again, but we've been here before. So we have to make sure that we go all the way to the end. Make sure all 4 of them work. Our last one is 49 divided by 21. What does 49/21 simplify to be? Keep on. 7/3. We have a winner. Okay. Because all 4 of those calculations are the same, yes, direct variation. Okay. Our second step, because it's yes, we can do the other 2 here. Write the equation of the line in slope-intercept form and find the constant of variation. What is the constant of variation? 7/3, right? That's why we care so much about what those equal. I'm going to abbreviate this COV, constant of variation. That is 7/3. And that constant of variation is important because it represents the slope of our line. So knowing that, what's the equation of this relation in slope-intercept form? Sasha. Brilliant. Y equals 7/3 x. Perfect. Okay. So we have 2 examples where direct variation does exist. One example where it doesn't. You've got 2 to do on your own here. Okay. And really do take it. I mean, as soon as you find one that's different, you can stop because they all have to be the same. But twice we ran into the first 3 being the same. You know, if we had taken a shortcut and just assumed the 4th one was the same as well, then we would have run into some trouble. So make sure that you are doing all 4 of them. Down below, the second part of your homework here, it says complete each table given that direct variation exists. So here we are assuming that it does. Write the lines equation in the slope-intercept form. Okay. So this first one, I've given you one ordered pair, 1, 3. Now, assuming that direct variation exists, give me a possible second ordered pair that could be part of this relation. Aiden?
9/3.
Which one does the 9? That's like a fraction. Where does the 9 go? Where's the 3 go?
3 on the first line.
Okay, the ordered pair 3, 9. Give me another ordered pair that's possible given direct variation exists. Connor?
6/12.
Not 6/12. And let's say an ordered pair, but if we had an x value of 6, what would the y value be? Nope, not 3. 18, right? Where these numbers are coming from is we're looking at that given ordered pair, that 1, 3, and if we take y divided by x, or 3 divided by 1, we get 3. which means that for all of our other ordered pairs, when we take y divided by x, we've got to get 3. 3, 9 works because y divided by x, 9 divided by 3 equals 3. 18, 6 works because y divided by x, 18 divided by 6 equals 3. So what's a fourth possible ordered pair here? Yeah. Close. 9 and 27, I think is what we're looking for here. 9 and 27, because 27 divided by 9 equals 3. Okay. And then it says, write the equation of the line in slope-intercept form. If the direct variation, this constant of variation is 3, then in our equation, y equals 3x. Okay, Aiden.
Could you put 721 in there?
721 would work as well. Yep. You kind of get to be a little bit creative here as far as the ordered pairs you pick, but it's got to follow that original constant of variation. So for this one, next one here, -3 and 4, y divided by x equals 4 divided by -3, which basically, since it can't be simplified, gives us -4/3. I'll give you another ordered pair that would work here, and see if you can tell me what I did to get there pretty easily. -6, 8 is another ordered pair that does work. How did I get there? I mean, you could test this. Does y divided by x equal -4/3? Well, yeah. -8 6 simplifies to be -4/3. But how did I get there so quickly and so directly without doing the y divided by x first? Yeah, I just doubled each of them, right? It's pretty slick. Okay. If you do the same thing to both values, you're going to get an equivalent fraction when you divide them. So someone give me a third ordered pair that would work here, following this direct variation of -4/3. Yeah. -12 and 16. Doubling what we just did again here, doubling -6, doubling 8, or going back to the original, multiplying -3 by 4 and 4 by 4 to get -12 and 16. Okay? And if we take that y divided by x, 16 divided by -12, we get that -4/3 again. Which is important because that being the constant of variation, when you write this equation in slope-intercept form, it's going to be y equals -4/3 x. Okay? All right, I've talked enough. Any questions that you folks have here? You've got 4 to do for homework for tomorrow. And if you kind of look ahead to what CO37 is, we are going to be applying this direct variation idea into the context of word problems, into actual situations where direct variation exists, and then be able to answer questions about it. So the background knowledge here of what direct variation is, how to write an equation when we know direct variation exists, that is what you need to carry with you in a CO37 tomorrow. So, all right, that's all you have for me. That's all I have for you. That is how you math. Oh, sorry. With gusto. That is how you math.